Okay, we're going to go ahead and get started with chapter 2. Now, with chapter 2, this is where the course really begins. Now, the first half of chapter 2, it kind of talks about this idea called limits. And I can't get to the big topic, which is something called derivatives, until we cover limits. So we're going to take about a class and a half to talk about this idea of limits, but it's going to seem a little weird. We will get to a certain point where I'm like, okay, this is what I'm really focusing on. Make sure you know this. So kind of bear with me a little bit as we go through, okay? So what do we know so far? If you had the function 2x minus 1, I could easily tell you, okay, what's the function at 2? And you would tell me 2 times 2 is 4, 4 minus 1 is 3, and you would get that without any issues at all. This is actually wrong. You would get 3, right? So 2, go to the graph, you would get the answer 3. Everybody comfortable with that? And if I told you, okay, what if it was negative 1? Okay, 2 times negative 1, that's negative 2. Negative 2 minus 1 is negative 3. Let's see if they got that right. Oh, they got that one right. So if you went to negative 1, you would get negative 3. So I can see that. We've done that. No worries at all. Everybody comfortable with that? But what we're going to talk about is taking that a little differently, looking at it a little differently, and we're adding this idea called limit, okay? The limit of a function at some domain value x equals a involving examining the behavior of the output values of the function as the input values get increasingly closer to the domain value of a. What you just heard was wah, 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 right? None of that makes sense. But what we're trying to find out is what happens to this function when we get to 2. So again, what we know is we have this function x plus 2. So if I was going to graph this thing, right, all of us know how to graph this thing. If I was going to graph this thing, the slope, the y-intercept is 2, so it starts at 2. The slope is 1 over 1, so I'd go up 1 to the right 1, and this is how I would get the line. All of us are comfortable with how to make a line. Everyone comfortable with that? And if I asked you right off the bat, what happens when you plug in, let's say, 2? You would say 2 plus 2 equals 4. And you can verify that with a graph, because when you plug in 2, you would get the answer of 4. Everybody totally comfortable with that? Okay? Here's what we're going to do. And this is going to look weird. This is like a preview before I really explain it all. I'm going to ask you this question, f of 2, but I'm also going to ask you these questions. And these questions are going to look like this. It's not going to make any sense right now, but we're going to practice it and it will make sense. I'm going to say limit as x approaches 2 with a little negative. And that negative means coming from the left. Coming from the left. What's the function value of that? Then I'm going to say, what's the limit as x approaches 2 with a little plus? And that's going to say coming from the right. Coming from the right. Then I'm going to say, okay, I checked it from the left. I checked it from the right. Now we should be able to make a determination. What's the limit as we approach 2? And those 3 questions are different than just plugging in 2. So take a minute, just kind of look at that. And then we're going to talk about this idea of a limit, right? And what a limit means is what happens as we get closer and closer to 2. Not when we get there. Not when we get there. But what happens as we get closer and closer to 2? I know it's weird. I know it's weird. I know it's weird. Okay? So, okay. This says I'm going to go closer and closer to 2 coming from the left. So here's the left. As I get closer and closer to 2, 2 is my goal. as I get closer and closer to 2, what is it approaching on the y? It's approaching 4. So as I get closer and closer, I'm following that line, heading towards 2 on the x, what value of y am I getting closer and closer and closer to? 4. Okay, so that says, as I get closer and closer to 2 coming from the left, I'm getting closer and closer to 4. We never get there. We just get closer and closer to it. Now, we're going to repeat that from the right. So as I follow this line from the right, as I get closer and closer to x2, what's the y value becoming? 4. Now, if those two answers match, coming from the left, I'm getting closer to 4. Coming from the right, I'm getting closer and closer to 4. Therefore, the limit as x approaches 2 is 4. There's your answer. How do I know? Because I checked it from the left, I checked it from the right, and you get 4. Now, what you know is if you plug in 2, you get 4. So now you're thinking, oh, it's the same stuff. Kind of. Here's the deal. The deal is this one has no problem. It's a solid line. Everything worked out perfect. So everything looks good. Are we okay? This is going to make more sense when there's a problem. What do I mean when there's a problem? When there's a hole there, when it jumps, when there's an asymptote there, then we can investigate really close, but not there. That's the idea of a limit. Because guess what? What we've seen so far is that what's 0 divided by 2? 0. What's 2 divided by 0? Undefined. And up until this point, you've said undefined and never thought twice about it. I want to see what's going on there. I want to find out, why is it undefined? And one way to do that is to get really, really close to it on both sides and see what's going on. So before we say undefined and never think twice about it. Now we're going to investigate. And the way to investigate is with limits. Are we okay? And you're still like super shaky. Don't worry. You're exactly where you need to be. You're exactly where you need to be. Okay? So looking at the notes, I've already kind of introduced this idea of looking at the limit coming from the left. That's when you're going to have a little negative. That means from the left. Looking at the limit from the right. That's when you have the plus. That means looking at it from the right. And if the left and the right are the same number, then the limit exists at that number. If not, then it's going to be something else. We'll talk about that soon. Okay? So we did that. Now we can do an example, and we're going to do several examples. So I'm going to give you a minute, and I'm going to ask you the best you can, draw that picture, the best you can, draw that picture in your notes. As you're copying this down, you're kind of noticing that this graph has some issues, right? It's not a straight line. It's not a nice curve. It's got some issues. Those issues are where limits come into play, right? So as I look at this one, from -2 to 1, it's a nice solid line. There's no issues. There's no problems. But at 1, there's a hole there. At 2, there's a jump there, right? There's some stuff going on. That's when the limits are really going to get into it. That's when the limits are really interesting, let's say. Okay? So we're going to go nice and slowly, and we're going to investigate, especially those weird ones. So what do you want to look at first? 1 or 2? What do you want to look at first? 1. Okay, so let's go investigate 1. So we're going to do the limit as x approaches 1 from the left. We're going to do the limit as x approaches 1 from the right. And we're going to do the limit as x approaches 1. Then, after I check all the limits, I'm going to see what happens when you plug in 1. So as you're writing that down, just take kind of a minute and realize the first three are limits from the left, from the right, what happens at 1. But the last one is just plugging it in. The last one is just plugging it in. The last one is just plugging it in. Okay? Now, having said that, let's go nice and slowly. Just to be clear, we're investigating 1. That's the focus, right? X is 1. So coming from the left, notice my little pencil moving. As we get closer and closer to 1, what Y value are we getting closer and closer to? 3. Perfect. So the limit as X approaches 1 from the left is 3. Now, coming from the right, I don't care how far right you want to go, but follow that graph from the right. Even if we start way at the end, following the graph from the right, as I get closer and closer to 1, what is the Y value that it approaches? 3. So coming from the left, it approaches 3. Coming from the right, it approaches 3. If those two numbers match from the left, from the right, that means the limit as X approaches 1 is 3. If they match, the answer is 3. Because remember, we're never getting to 3. It's getting super, super close, from both sides. So the limit exists out of 1 at 3. Good so far? But that is a totally different question than what happens when you plug in 1. When you plug in 1, you notice there's a what? A hole. So what do you think the answer is going to be? Undefined. Now, again, when you plug in 1, you get undefined. We would say there's nothing going on. But at least now I know, coming from the left and coming from the right, it is approaching 3. There's just something unusual there. There's a hole there. They are both sides going to 3, but there's a hole there. Are we okay? Now, again, I know it's weird. Now I'm going to ask you to try one on your own. The other part that has an issue is what number? 2. So let's now focus on 2. And I'm going to ask the same questions. The limit as X approaches 2 from the left. Limit as X approaches 2 from the right. And the limit as X approaches 2. And a completely separate question, what happens when you plug in 2? Okay, take some time. I'm going to walk around, see if you have any questions. So let's go look at 2, but before we do anything, can we all agree that 2 has some issues? Okay, so keep that in mind, okay? So using the little cursor, as I get closer and closer to 2 from the left, I can go anywhere from the left, but as I get closer and closer to 2, what is the Y value getting closer and closer to? 2. Good so far? Now, coming from the right, as I get closer and closer to 2, what's the Y value? 5. So here's what we're learning. From the left, it's getting closer and closer to 2. Coming from the right, we're getting closer and closer to 5. Do those numbers match? Now, the proper answer when those numbers don't match is DNE. Does not exist. The limit does not exist. Why? Because it's going to 2 different numbers. Okay. Now, some people put undefined there and they're like, isn't undefined the same thing as does not exist? Technically, they're a little different. This one's saying, since they don't approach the same number, it does not exist. One's going to 2, one's going to 5. We've investigated that there's something going on there now, right? But the limit does not exist. They're going to 2 different numbers. Are we okay? Now, if you plugged in straight 2, I plugged in 2, would it be the filled in or would it be the open circle? The filled in, so the answer for that is something we knew beforehand, which is 2. It is a separate question. Are we okay? Now, Notice that really the only places we have an issue are at 1 and 2. The reason why we're confused is because when there's an issue, okay, this has a purpose. When there's not an issue, it seems weird. So I'm going to give you one that's not an issue, not an issue. I'm going to tell you what happens at 0. What happens at 0? I'm going to tell you the hint ahead of time that there's nothing wrong at 0. There's nothing wrong at 0, but I can still ask you the same questions. I can still ask you, what is the limit as x approaches 0 coming from the left? What is the limit as x approaches 0 from the right? What is the limit as x approaches 0? And again, a completely separate question. What happens when you plug in 0? Okay, so give that a try. Give that a try. And we'll go over it. So, looking at 0 coming from the left, as we get closer and closer to 0, what number of y is it approaching? 2. Coming from the right, no matter where you want to go on the right, as we get closer and closer to 0, what value of y is it approaching? 2. Since the numbers match, what's the limit as x approaches 0? 2. And when you plug in 0, what do you get for an answer? 2. So you're like, it's too easy, because there's no issues. There's no problem. There's no hole. There's no jump, soon, no asymptote, right? So when it's a nice smooth line, there are no problems. It's when there's a hole or a jump, limits really come into play. It's when you get undefined and you're like, why is it undefined? Let's go look at it. Let's get really closer from the left. Let's get really close from the right. And then we can investigate what's happening there. Not too bad? All right. So again, we're not going to get too crazy in depth with this stuff. You're getting what I need you to do, but there's more examples in the notes if you want to practice. There's a ton more examples. The answers to the notes are on the bottom of the notes. There are some theories, just like when we talked about log theories, they're nice to know. We're not going to get into them. We're going to kind of use them as we go, but that's just one nice table of all the theorems. Nothing too crazy that we need to worry about. We'll kind of use them as we go, but you're going to start to get to a certain idea. And the idea is, if there are no problems, you just plug in the number. If there are problems, then we have to investigate. So here's where all that algebra is starting to come in. So if I want to find out what happens as you get to 2 of this function, I'm going to ask you some information about that function. What shape is this? It's a parabola. It's a nice, smooth parabola. Are there any holes? Are there any jumps? Are there any asymptotes? And nothing. So if I understand that this is a parabola, it's a polynomial is what it falls under, I can just plug in 2. Because 2 squared minus 3 times 2, that's going to give you 4 minus 6, which gives you -2. Because just like we did for the 0, if there are no problems, it all ends up being the same answer. Are we okay? So the question is, can you identify if there's going to be a problem or not? I can identify that this is a parabola. This is a polynomial. There's no jumps, no holes, nothing going on. So I'm just going to plug the number in. And if you're looking for the limit or looking for the number, you're going to get the same answer, -2. You're going to get the same answer, -2. Okay, so we're going to get to that point. We're going to get to that point. So if you have a polynomial, right? Linear, quadratic, cubic, all those different things, the limit is going to be the same thing as plugging in the number. It's the same because there's no hole, there's no jump, there's nothing going on. But if you have a rational function, remember what that means. A rational function is where you have a function on top, a polynomial function on the bottom. Remember? This one, you need to be careful. And you need to be careful at certain places. Where do you definitely need to be careful? Which one? when the whatever makes the denominator 0. So again, I don't care what the number is up top, but if there's something that makes that denominator 0, that's going to make it undefined. That means there's something going on. And that undefined could be an asymptote. It could be a hole. It could be a jump. But that's where we got to be careful. But if it's not a rational function, just plug in the number. Life is great, right? So looking at these two, actually these four, let's talk about each one. The first one, will this one have any issues at all? Nope. Why? Because it's to the fourth power. It's not dividing by anything. This is a polynomial. So simply plug in the number 2. This one, okay, cube root. I know some of you are thinking you can't take the square root of a negative, and you're totally correct. But can you do a cube root of a negative? Yeah. So does any number work? Yep. This one has no problems. You simply plug in 1. Now, this bottom one, you're like, ooh, that could be a problem, because what could make the bottom 0? Something, right? But what number would do that? See if you can do it in your head. What number would make this denominator 0? -2/3. Because if you put -2/3, 3/3 is 1, -2 minus 2 is 0. So just trust me that if this was x -2/3, the bottom would become 0. Are you with me? But what about any other number? Any other number is fine. What number am I plugging in? So is 2 okay? So just plug it in. And then the last one, same idea. What can x not be? 0. Am I trying to plug in 0? So is it okay? So you've identified for these 4, plugging in those numbers has no impact, no issues, right? So all you have to do for these 4, because you've identified that, is plug in the number. So what I'd like you to do is all 4 of these, just plug in the number, because taking the limit and just plugging it in will be the same. Taking the limit and just plugging it in will be the same, because we understand now. We understand now. We understand now, I hope. Okay, so give those 4 a try. And as you're doing those 4, understand I can just plug in the number because there's no issue. They don't have to worry about the limit. Those work okay. As we look at each one, again, there's no issues plugging it in. That's why we're able to. What do you get for the first one? 21. What do you get for the second one? 0. That should be 0, because that's 1 to the 4th is 1. 1 times 2 is 2. This would be 1 squared. It's 3. 2 minus 3 is -1. -1 plus 1 is 0. Cube root of 0 is 0. What do you get for the bottom left one? 7/8. And the absolute value of 4 is 4. 4 divided by 4 is 1. Are we okay? No issues at all, because we understand there's no problems plugging in those numbers. Okay? And when it's like that, the limit and plugging in are the same, just like we did with the 0 earlier. Okay? Now, I just want to throw in that this may be kind of related to piecewise functions. When it looks like one from one, it looks like one from another one. And it's just like the idea is that you have certain restrictions. So I just want to go over this one real quick. This is saying, notice that for A, B, C, and D, what number are we plugging in? 2. The focus is on 2. A piecewise function says, use this function when x is less than or equal to 2. Use this function when x is greater than or equal to 2. Are we okay? Now, this one says coming from the left. So what happens when you take 2 and coming from the left? Since we're coming from the left, will we use, and I'll put it over here, A, will we use less than 2 or more than 2? The less than 2. So this will be x squared plus 1. We're plugging in 2. That's 4 plus 1. You'd get 5. Okay? B. This one says coming from the right. So will I use the first or the second one? The second one, x minus 1. So 2 minus 1 is 1. Then C, you checked it from the left, you checked it from the right. Did they match? Nope. So what's C going to be? DNE does not exist. And then D, completely separate question. What happens when you just plug in 2? Now be careful. It's all about the details. This one says, the top one says less than 2. The bottom one says more than 2. Which one says equal to? Neither one. So what's the answer? Undefined. So again, I know that's a little weird, but there is kind of a relationship between piecewise functions and what we're doing, coming from the left, coming from the right, coming from the left, coming from the right. Okay? Now, let's try to bring this all together. Let's try to bring this all together and look at graphs and things like that. So the first example we're going to do, I'm going to put it up here so we have a little space, is A. A says the limit as x approaches negative 3, as x approaches negative 3 of x squared plus 4x plus 3 divided by x plus 3. Now, I do have a little disclaimer. You should always simplify first. You should always simplify first, then deal with it. But I'm going to leave it as is for this example. I'm going to leave it as is for this example, and you'll see why in a minute. Okay? So what I want to do first is graph this. What I want to do first is graph this. So I'm going to go to my calculator. And again, I'm going to be very careful when I graph this. And I'm going to do it in a normal window because you want to see the negative 3. So I'm going to go to my calculator. I'm going to go to y equals. Again, we should all be comfortable with the calculator. If you have the plot one on like I do, go up to it, hit enter. Make sure all the plots are off. And let's put that in parentheses. Parenthesis, x squared plus 4x plus 3, close parenthesis, divided by x plus 3. X plus 3. Enter. Good so far. Okay. Now I'm going to hit zoom 6. That gets me a normal window. Zoom 6. Zoom 6. Oops. Zoom 6. And that's the graph. Okay. So I'm going to do the best I can, kind of draw that graph in my notes so we can refer back to it. Okay. So I go to the notes. Just going to do a little sketch of it. And again, if you need to remember, we did 10, negative 10, 10, negative 10, if that helps you remember. Okay. Now, before we even get started, like I just taught you, are we concerned about plugging in negative 3? We are, because remember before, if you could plug it in, it's no problem. Is negative 3 a problem? Yes. It's a problem. Why is it a problem then? Why can you see that right away? Negative 3 plus 3 in the denominator gives you what? So we know there's a problem here. So we're going to go through all of our steps. The limit as x approaches negative 3 from the left. The limit as x approaches negative 3 from the right. The limit as x approaches negative 3. And then just plugging in negative 3. Good so far? So I'm going to try my best to show negative 3 well. Okay. So I'm going to kind of focus in right here, right here, right here. Okay. There's -3. And that would be -2. Okay, I can make it a little bit larger for you. So you tell me, as we go through this nice and slowly, coming from the left, as I approach -3, what's the y value? -2. I'm going to pause there and let you do the rest. I'm going to pause there and let you do the rest of this. So coming from the right, as we get closer and closer to -3, what's the y value? -2. Therefore, if from the left is -2, from the right is -2, what's the limit as we approach -3? -2. Now, this is what's interesting. If you look at the graph, it looks like a beautiful solid line. That's a graph. Looks like a beautiful solid line. But then go to the table feature, second graph, type in -3. When you put in -3, enter, it says error. Weird. Looks like a solid line, doesn't it? And I'm going to show you another trick. Go to graph. If you hit second trace, press number 1 for value, you can tell it the value, -3. And it's funny, when you put -3 and it hit enter, what does it show you? Blank. What? This is what's interesting. If I showed you this graph, you would say it's a nice, beautiful graph, but it's actually not. What do you have at -3? A hole, an open circle, right? And how did we know that? How did we investigate that? Because we did limits. Are we okay? Yes, it approaches -2 from both sides, but it's undefined at -3. Are we okay? So again, hopefully it's coming up to it's starting to make a little sense why we do this. So let's do another one. Now this one's going to be a little weird to graph, so I want to help you graph it. But let's do this second one, B. And with B, we're taking the limit as x approaches 4 of x squared minus 16 in parentheses over absolute value of x minus 4. Now again, we should be getting to the point where I look at it and I'm like, a little alarm should go off. And the reason why an alarm should go off is I can see 4 minus 4 is 0, absolute value is 0, 0. I can't have 0 in the denominator. So we should clearly see this one's going to be a problem. Okay? Now, to graph this one, let's do it together. It's still going to be in a normal window, but we're going to go to y equals. We're going to put parenthesis x squared minus 16, close parenthesis, divided. Now, everyone's calculator is a little different, but to be safe, I'm going to put the bottom in parentheses. Where's the absolute value? Absolute value, you press math, to the right for number, choose number 1 for abs, And for me, inside, I'm going to put x minus 4. Then on the outside, I'm going to put a parenthesis. If yours has absolute value parenthesis, you have to close the parenthesis and then close the parenthesis again, but make sure that x minus 4 is in the parenthesis. Then you can do zoom 6, or if you still have zoom 6, there's your graph. Now, we're going to be looking at 4. We already knew there was a problem, and do you see the problem? Right? So we're going to graph this. The best we can, and then we're going to answer those questions. We're going to graph it the best we can and answer those questions. So just like we were doing before, and notice how we have to know how to graph. We have to know all these different things. And I'm just doing a little sketch. It's not going to be perfect. But 1, 2, 3, 4 is my goal. And no, it's not perfect. And we're gonna, I know I'm gonna kind of squeeze all this in here, but we're gonna do the limit as x approaches 4 from the left. Limit as x approaches 4 from the right. The limit as x approaches 4. And plug in 4. Okay, so give that a try, give that a try. And again, it's all kind of building, it's all building. The more practice, the better. The more practice, the better. Okay, so the focus is on 4. The focus is on 4. Coming from the left, trying to use your calculator, plugging in the number, playing around with it. I know it could be a little difficult, but coming from the left, what number is this approach? -8, -8, -8. Coming from, that shows up pretty good. Coming from the right, what number does it approach? +8, +8, +8. Since those numbers don't match, what do you get for the limit? Does not exist. And what happens when you try to plug in 4? It's undefined. Questions there? All right. Last big topic we're going to talk about is called indeterminate. Indeterminate means when you plug in the number and you get 0/0, that's called indeterminate. If that happens, that's a big clue that you're not done. You're not done. And as a general rule, you should always simplify first. But people forget. People don't do it, right? So if you get 0/0, that's a reminder that number 1, you're not done. Number 2, you should have simplified first. So what do I mean by that? You know that if you plugged in 2, you would get 0 for this function. But what actually happens is you get 2 squared minus 4 over 2 minus 2, which gives you 4 minus 4, which is 0/0. When that happens, we have a name for it. It's called indeterminate, which means we don't know. Undetermined, right? Indeterminate. We don't know. And when that happens, that means you should have factored the top, factored the bottom, and simplified. Again, you need to know how to factor, right? But that 0/0 is a big clue. That's what you should have done. So x squared minus 4 is x minus 2 over x plus 2 over x minus 2. So x minus 2, this simplifies to x plus 2. This simplifies to x plus 2. Then plug in the 2, Now that it's simplified, 2 plus 2 gives you 4. Okay, so 4 would be your answer. So if you get 0/0, I know initially you're like, uh-oh, this is going to be undefined. It's not, because it's not simplified. This really means x plus 2. This is x plus 2. So can you plug in 2? Yes, you can plug in 2, but you don't realize that until you simplify it first. Okay? And again, from the original, there could be a hole or something like that, but what's happening at 2? You get 4. What's happening at 2? You get 4. So bottom line, if you get 0/0, do that extra step. And that doesn't mean it's always going to happen. It doesn't mean it's always going to happen. Like, for example, you may look at this one and you're like, uh-oh. But if you plugged in 2, you don't get 0/0. You get 0/8. And is 0/8 okay? Yeah, that's 0. Remember, it's only if 0's in the denominator. It's only if 0's in the denominator. Okay? Only if 0's in the denominator. Now, what I'd like you to do, for this last one, is I want you to simplify this one first. Go ahead and simplify first. You actually get 4/0 when you plug it in, which is undefined. But see what happens when you simplify it. And let's talk about why is it undefined. And that's where I'm going to end today, is why does this end up being undefined? There's a reason that this one is undefined. So simplify it first, then we'll talk. Simplify first, then we'll talk. So we just had a question. I wanted to go back and say, the question was, in this example, is it still undefined? Yeah, if you try to plug in 2, you're going to get a hole. And if you try to plug in 2, it is undefined. This is talking about the limit. The limit will be 4. The limit will be 4. But if you plug in 2, it's going to be undefined. So I just want to clarify that. And then for this one, let's see if we simplified correctly. This would be x plus 2. The bottom would be x minus 2, x plus 2. So x plus 2 over x plus 2 leaves you with 1. We get 1 over x minus 2. Now, I want to graph this, and I want to look at what's going on at 2, because the question is the limit as x approaches 2 of 1 over x minus 2. That's the question. That's the question. That's the question. So we go to the calculator. We go to the calculator. We go to y equals. And we're going to put 1. Again, be careful you type it in correctly. This one ends up being 1 divided by parentheses. Without the parentheses, it will be something else. X subtraction, not negative, subtraction 2. We're going to keep it. We're going to keep it in a normal window. Zoom 6. And this is going to be kind of the beginning of next section, but I'm going to give you a little preview. When you draw this in your notes, the graph looks like this. I'm going to put it up here. 2. The focus is 2. You get the left side going like this, and you get the right side going like this. Are we okay? Now, we're going to do this together because I haven't taught it, but it is the beginning of the next section. So this is the question. And we're going to have the limit as x approaches 2 from the left. The limit as x approaches 2 from the right. The limit as x approaches 2. And what happens when you plug in 2. Okay, so this is new. We haven't talked about it, because not only can it approach a number, what else can it approach? Infinity. And remember, infinity going upward is positive infinity, downward is negative infinity. To the right is positive, to the left is negative. So, more options. As we approach 2 from the left, where is this thing going? Where is it going? Negative infinity. As we approach this from the right, where is this going? Positive infinity. Now, just so you know, if they were both positive, the limit would be positive. If they were both negative, the limit would be negative infinity. But since they're different, what are we going to put? Does not exist. And what happens when you plug into? Undefined. Now, how does this all connect with what we've been doing? You've just discovered through limits that you have a what? What's this thing called? Which one? You have a vertical asymptote. And what's the equation of that vertical asymptote? X equals 2. The line is x equals 2. So you've discovered through limits that there's a vertical asymptote. Through limits, you can also discover a horizontal asymptote. So in addition to going to a number It can also go to negative infinity or positive infinity. That's where we're going to pick up next class. Now, next class, if you really want to be ready for next class, make sure you review what we've already covered about vertical and horizontal asymptotes. So I don't have to teach it all over again. That's basically going to be the next section, and then we'll get to section 2.3. But with this, we're done with 2.1. Notice that there's matched problems. Notice that there's more examples. And notice that the answers to all the matched problems are here. So if you want to do more examples in the notes, they're all there for you. But where we'll start next class is 2.2. 2.2.